So thanks for coming, guys. As you probably know, 0x is it's a decentralized protocol for trading tokens, and I appreciate you taking time out of your Sunday to come listen to how the world's going to look in 10 or 15 years. So this is Will Warren. I've known Will for a while now. I still remember a year and a half ago, we were sitting in a dinky little office in the Mission, coding Solidity, trying to figure out how everything worked. And it's come a long way since then. So yeah, Will has started this project called 0x, and he's got a nice team. They have an ICO coming up in August, and he's going to give a technical overview of how it works. So without further ado, here's Will. Thanks.
Thanks, Grant. Hi, everyone. My name is Will. Thanks for coming to check out our presentation. We're really excited to be presenting today to all the San Francisco Ethereum fans. Grant, Linda, Tim, thank you for organizing the event. It's amazing how much it's grown. I remember, not that long ago, coming to this same exact venue, and there was maybe like 12, 18 people. And we'd go around and ask everyone to like introduce themselves, and I don't think we could do that today. So a little bit about our team. Amir, my co-founder, and I started working on 0x about 10 months ago. Since then, we've put together an awesome team. Today, we have every single member of the team here. Fabio, Leo, Alex. Fabio is actually going to be giving a little bit of a demo later on in the presentation. We're a globally distributed team, so Fabio's from Switzerland, Leo's from Poland, the rest of us are all based here in San Francisco, but we're going to be growing. So,
if you're based in San Francisco, make sure to reach out to us after the presentation. We also have an awesome group of advisors, partners that are building on top of 0x, and some great investors as well that have allowed us to get to this point. So without further ado, the overview of the presentation. So I'm going to start out by providing some motivation and a little bit of background on the problem that we're trying to solve with 0x. Then I'm going to go through some of the existing work that we did like a peer review. We went through all the sort of existing solutions for decentralized exchange, and I'm going to kind of give a high-level overview of each one, their pros and cons. Then we're going to dive into 0x protocol, give an overview of sort of how it works at a high level, then go into the smart contract architecture, which will be a little bit more technical, and then we'll talk about something called token abstraction, which we're excited to talk about today. Fabio is going to come up and present 0x.js. We just released it last week. It's the official JavaScript library for 0x protocol. So if there's any web developers out there that maybe aren't experts in Ethereum, it's something that you'll definitely want to check out. Then cover our hackathon, kind of give a timeline and overview of our project, and then wrap up with a Q&A. So the world is becoming tokenized. Just since the Ethereum blockchain launched a couple years ago, tokens and value are rapidly accumulating on the Ethereum blockchain. So today there are already around 30 different ERC20 tokens that sit on top of the Ethereum blockchain, and their combined value is, I actually don't even know. I have to change this slide every week, and I forgot to do it this time. There's also like 100 different decentralized applications that exist today. But we think that by 2020, there's going to be thousands of tokens on the Ethereum blockchain. And not just ICO tokens, but things like traditional securities, things like stocks, bonds, derivatives, fiat currencies will be tokenized, as well as like other scarce digital goods, things like loyalty points, airline miles, video game items. All of these things will be moved onto the Ethereum blockchain and they'll become liquid. Once this happens, we estimate that the combined value of all these tokens will be in the tens to hundreds of billions of dollars. And there's going to be many thousands of decentralized applications that exist in not too long. Each one of them might have their own token. Naturally, there's going to need to be a way of exchanging tokens. So the current ecosystem on the Ethereum blockchain, there's a handful of decentralized exchanges that exist today. There's also a handful of decentralized applications that require exchange functionality in order to operate. So examples of these would be like prediction markets, decentralized fund management platforms like Melonport and Neufund, things like stablecoins that require liquid markets in order for the stablecoin to remain stable, as well as a bunch of other examples that we're not going to go into. So the issue with the current ecosystem is that each one of these exchanges and decentralized applications has to create their own custom and proprietary smart contracts for exchange. And this means that each dApp and each exchange must bootstrap liquidity from scratch. And it also means that there's no interoperability between any of these different exchanges. Even worse, for the end user, instead of having a single smart contract that handles the exchange of tokens, they have to expose their valuable digital assets to 20 different decentralized exchange smart contracts. Each one has different levels of efficiency and security. They each have different configuration processes and learning curves. So this is just like a very non-ideal way to build an ecosystem. So in our view, smart contracts should act as modular, unopinionated building blocks that can be assembled and reconfigured. And we also believe that open standards tend to win out in the long run. So now I'm going to briefly go over some of the current implementations for decentralized exchanges on the Ethereum blockchain. So the very first type of decentralized exchange that was created in an Ethereum smart contract basically tried to take all of the functionality of a traditional centralized exchange and pull it into an Ethereum smart contract. And so what they ended up doing is building an order book, essentially a list of bids and asks that indicate interest in buying or selling on a specific trading pair. They took this entire order book and they pulled it into an Ethereum smart contract. And as a result, every time you want to place an order in the order book, modify an order, or cancel an order, you have to end up paying transaction fees, gas costs, in order to do so. And what this means is that it's extremely expensive, it's prohibitively expensive to be a market maker. If you can imagine having to pay 10 cents, 15 cents every single time you're modifying your orders. On traditional exchanges, centralized exchanges, market makers are modifying dozens of orders. Sometimes they're doing it 10 times per second. So it's just completely unrealistic that you'll be able to have liquid, efficient markets within an on-chain order book. Another issue with on-chain order books, they bloat the blockchain. So every time if you have an order sitting on the order book, if you want to make a slight adjustment to the exchange rate you're willing to accept, well, guess what? Thousands of Ethereum nodes all over the world are going to have to record that change in perpetuity until the end of the Ethereum blockchain. That's not a very efficient way of operating an exchange. The second class of decentralized exchanges on the Ethereum blockchain are called automated market makers. And the way that automated market makers work is that each party on either side of a market, they trade directly with a smart contract rather than with each other. And the smart contract has a deterministic model that relates the price of a trading pair with the market forces that are pushing it in either direction. And so the prediction markets, Augur and Gnosis, they've been around for a long time now, over a year. And their sort of initial approach to exchange was to build an automated market maker. And essentially what they found is that automated market makers just really don't work very well for moving large amounts of value. And the reason is because if there's two parties on either side of a market and they want to just do a trade, they can't do it directly. Instead, they each have to take all of their value that they want to exchange, they have to chop it up into little chunks, and they have to pass it through the market maker, automated market maker, back and forth. And if they don't, they'll end up just completely tanking the price or shooting the price up to a ridiculous level. So automated market makers are low throughput. They're also really vulnerable to front running. So if someone sees that you're placing a trade to sell some reputation tokens and that transaction's sitting in the Ethereum mempool, it hasn't been mined yet, someone can see that and they can go and dump a sell order right in the mempool and place a high gas price, and they can tank the exchange rate of rep for whatever it is you're trading before your trade gets mined, which is really bad. I'm sure you can imagine it's not very fun when you think you're getting one price, but you get one that's 20% lower. Another issue is that since the relationship between price and market forces is deterministic, automated market makers are gameable. So Augur and Gnosis, they sort of eventually abandoned the idea of using automated market makers for really moving value. Gnosis did publish an interesting blog post that explained how automated market makers can be really useful for having an on-chain price feed. So you have a smart contract that is able to kind of provide you a feed of an exchange rate directly on the blockchain, which is useful, but ultimately that's not what you really need if you want to have liquid markets that can support lots of volume. So the last class of decentralized exchanges are state channels. And so actually we have Amin here, who's an expert in state channels. He's here today. So if you have questions, go talk to Amin after the talk. State channels are really awesome. Essentially what state channels do is they let you move value off of the blockchain with a counterparty in the channel with you. And you can do a bunch of sort of intermediate state changes, and these are off of the blockchain. They're not being recorded, there's no transactions on the blockchain. You take all of these intermediate state changes, you kind of aggregate them into a single final state, and you kind of dump this final state onto the blockchain, and that you're paying the transaction fee to kind of finalize the state channel and to open it up, but not for anything in between. Another really awesome thing about state channels is that you're not limited by the latency or the throughput of the Ethereum blockchain. So you can do like really low latency trading. You can do a lot of things that you're limited by on the Ethereum blockchain. One of the downsides to state channels is that it requires multiple transactions on the blockchain in order to open the channel and close the channel, ensuring each party in the channel is behaving honestly. It also requires that each party in the channel place a security deposit into the channel to ensure that each party is behaving honestly. And there's also a challenge period. When you're closing the channel, you have to ensure that there's a period of time during which you can challenge your counterparty if they're trying to lie and steal. So as a result, say you just want to do one block trade, you just want to sell some ether, you want to sell some rep, and you just want to do one trade and be done with it. With state channels, it requires multiple on-chain transactions, there's a security deposit, a challenge period. It's kind of a pain. But if you're doing something like high-frequency trading, something where you're doing lots of transactions all the time, state channels are great. Another limitation of state channels is that once you move your funds into the channel and you're sort of isolated from the blockchain, the participants in the channel cannot actually interact with smart contracts. So all the cool functionality that you might want to access that is located on the Ethereum blockchain, you can't really interact with smart contracts at all. So those are the three sort of high-level classes of decentralized exchanges that exist today. So how does 0x work? 0x uses something called off-chain order relay with on-chain settlement. And what this means is essentially that you generate an order, which is just a package of data, and this package of data specifies the different assets that are going to be traded, the exchange rate that's going to be traded, an expiration time, which is sort of determines how long this order will remain valid or can actually be executed, and a cryptographic signature of all of the parameters specifying the order. And essentially what you do, if you want to place an order on an order book or trade with a counterparty, you generate this data packet specifying all the parameters of the trade that you would like to make, you cryptographically sign it with your private key, and then you broadcast this chunk of data to your counterparty off of the blockchain. So generating this data packet, this order, and broadcasting it to your counterparty, that's all done off of the blockchain, and there's no Ethereum transaction required. Now, the way that you transmit this data packet to your counterparty is not defined. You can write it down on a piece of paper, and you can tie it to a carrier pigeon, and you can have that carrier pigeon fly to your counterparty's house. And assuming the cryptographic signature is valid, your counterparty can then take this order, inject it into a smart contract on the Ethereum blockchain, and that smart contract will then authenticate the signature. It will verify that each party has the required balances of tokens. The smart contract will verify that the order is not expired. And then, assuming everything checks out, the smart contract will settle the trade and move balances between the different counterparties at the specified exchange rate. So, before I go on, are there any questions? Is that clear? If not, please raise your hand and let me know. Okay.
I have a question.
Yep.
How do you cancel an order?
So if you want to cancel an order, you can either set an expiration time that is relatively short. So if you're willing to make a trade within the next hour at a specific exchange rate, you set an expiration time for 1 hour. After that hour, the smart contract will automatically reject any attempt to fill that order. If you want to cancel that order immediately before the expiration time, you actually do have to send this order to the smart contract and cancel it on the blockchain. Yes?
You said low latency. How fast is the protocol?
So since trades are settled on the Ethereum blockchain, settlement latency is limited by the latency of the blockchain, as well as the throughput. So the number of transactions per second is limited by the throughput of the blockchain.
What about orders?
So orders, since they're done off of the blockchain, it's really just, the network transport layer is not defined. So you can use sort of whatever you want. Yes?
I think I didn't quite understand which part of what you described is 0x, or like what is 0x providing? Is 0x providing a smart contract? Is it providing a way to like communicate with the other participant? Like, yeah.
Right.
Does that make sense?
Yeah. So 0x is specifying a standard message format, which is how you arrange these order parameters into the data chunk, how you sort of process them and cryptographically sign them. How you broadcast that to a counterparty is not defined, but the smart contracts that accept this order and actually settle trades is defined. That is a part of the protocol. But we're going to talk about that more in the next slide. Yep?
How are the funds unlocked, or is there like a deposit period?
Yes. So good question. The question is, how does the smart contract that's executing trades access your tokens? And so this is something that I'm going to talk about a little bit later. The short answer is that ERC20 tokens, they not only allow you to transfer your balance to someone else, but they also allow you to provide access to someone else. And that someone else might be a smart contract. Assuming that it is a smart contract, you can usually expect the code to be open source, and you can inspect the code and verify that you're comfortable providing that access. So before we move on, so what I've described so far is just a generic method of creating an order off the blockchain cryptographically signing it, and passing it to a counterparty, which is great if you know your counterparty. But frequently, most frequently, trades are done on exchanges where there's sort of a public location where you can create an order, put it up on sort of an order book where anyone can go and look and see your order and decide to fill it. So what we have described so far does not provide for such a public location where orders can be aggregated. So this is where relayers come in. Relayers are sort of they're sort of a big part of how 0x protocol is unique from everything else that exists today. So relayers are any party that decides to host an off-chain order book and essentially serve this order book to other people that might be interested in making trades. And a relayer can be anyone. So using 0x protocol, anyone can be a relayer and anyone can essentially spin up their own decentralized exchange. You don't need to pay anything, you don't need our permission. If you can go and create a nice web app that accepts these cryptographically signed chunks of data and serves them to users, then you can be a relayer and start charging transaction fees. So within the order message format, there are these different fields here, fee recipient, and that's where you plug in the Ethereum address of the person that is relaying your order, such as the exchange. And then there's also maker fee and taker fee fields. So the way in which you sort of negotiate transaction fees with a relayer is shown in the diagram here. So essentially what happens is that if you want to generate an order and place it on a specific relayer's order book, you go to that website. It looks and feels just like a normal exchange web application. You say, hey, this is an order that I want to place on your order book. You get a response from the relayer that says, okay, if you want to place this order on my order book, you must set the fee recipient address to X, and you must set the maker fee and the taker fee to Y and Z. You get that message back. You generate your order with those parameters as specified. You cryptographically sign that entire data packet, and then you broadcast that data packet back to the relayer. What the relayer will do is they will check that you provided the necessary fees. If not, the process ends there. If you do, the relayer will add your order to their order book. Then this new updated version of the order book will be sort of broadcast to all the different other traders that are looking at that same web application. If someone sees your order and decides to take the other side, they simply take that data packet and they inject it into the 0x smart contracts, and the smart contracts actually settle the trade. At the point at which a trade is settled, that's when transaction fees are transferred from the maker and the taker to the relayer. So fees are only paid to the relayer upon settlement of a trade, just the same way it works for any centralized exchange today. Everyone comfortable with that?
Is the fee specified in the message sent by the person who's placing the order?
Correct, yeah. For both the person that's generating it, the maker, as well as the person that's filling the order, the taker.
So each of them sets a different fee, or?
No, so the relayer will specify the maker fee and the taker fee, and then the maker will say, I'm the maker, I'm fine paying that fee, so I will do that. If the taker is comfortable filling that fee, then they'll fill the order. If not, then they won't. Another thing that's really, so just backing up a second, the last slide, the takeaway message is that anyone can be a relayer, anyone can be a decentralized exchange. Everyone uses the same smart contracts, everyone uses the same message format. And by the way, it's completely free. So every time you as a relayer, you generate a trade that gets executed, you keep 100% of the transaction fees. 0x, the team behind 0x, the developers, we don't take any of it. It's completely non-rent seeking, as it should be. Another really sort of compelling thing, yeah?
If you're a relayer, you have to get the maker to provide access to your smart contracts before they do everything.
Right, so the providing access to your funds that is done to sort of the same set of smart contracts that sort of comprise 0x protocol's smart contracts. So let's say if you're trading on 3 or 5 different relayers, you provide access to the same exact smart contract. You don't have to provide access to any given relayer.
So,
Yes?
so what happens if there are 3 trades that simultaneously get executed and you don't have enough funds?
Right, so this is a race condition. What happens if there's sort of 3 different orders that are assigned to the same set of funds, 3 people try and fill those orders at the exact same time? This is a race condition. And so there's various strategies that can be used by relayers to completely prevent race conditions from occurring. I think I get into it a little bit more later in the presentation, but if I forget, ask me in the Q&A. So another thing that's compelling about 0x is that it allows for integration with other decentralized applications natively on the blockchain. So when you think about decentralized exchange, you probably think of like a Poloniex or a GDAX, where you're sitting in front of your laptop and you're plugging in orders and filling trades, sort of in like an exchange user interface. But 0x actually allows for something that's completely separate. Other people can generate smart contracts that execute trades programmatically in a single line of Solidity code. So you can think of these dApps as sort of using the 0x smart contract API. Another thing that's really interesting is that since every relayer and every dApp that is built on top of 0x uses the same exact message format, if you want to use a dApp that is going to execute a trade, you can pull an order off any order book and pass it into that smart contract to execute a trade. So now I'm going to talk a little bit about network effects. So what are the benefits of creating an open protocol where anyone can participate? And what are the challenges that you come up with when there's adoption? So all of the current decentralized exchanges that exist today can kind of be represented by this plot. So there's a single relayer, a cloud, and that's sort of like the relayer's liquidity pool. And that liquidity pool feeds into a sort of back-end infrastructure. It might be a smart contract, it might be a centralized exchange, whatever. But it's really a closed system. 0x is not like that, since anyone can be a relayer. Since 0x allows anyone to be a relayer and anyone to spin up their own exchange, it creates these network effects around liquidity. Since everyone's speaking the exact same language, it creates additional liquidity for each relayer because they are each using the same message format. So Metcalfe's law states that the value of a network is proportional to the number of nodes in the network squared. For the network of relayers that exist on top of 0x, each relayer is a node, and the interconnections between them is sort of proportional to the value or the amount of liquidity that is provided by this network of relayers. So you can imagine that each relayer has their own liquidity, and that liquidity is, these trades are being sent to the 0x smart contracts, but there's also arbitrage opportunities across different order books, which results in a greater amount of volume for each relayer. And then the second point, integration with dApps. So what's the second sort of network effect that's created by having a completely open protocol that can be integrated with dApps? Now, not only do you have different relayers that essentially create their trades and arbitrage across different relayers, creating more trades, but different dApps can pull liquidity from each order book, resulting in even more interconnections and volume. Now, after all of these interconnections are established, comes a really important question. You have this system, there's all of these interconnections. Thank you. Okay. Yeah, all right, can you hear me?
Testing, testing.
That's fine, I'll just speak. Can you guys hear in the back? Okay. So, as a relayer, why would you want to use an open protocol rather than just create your own custom smart contracts, have your own little closed system? Well, it's because not only are your customers other relayers, but your customers are also every single dApp that plugs into 0x. So that means that your volume scales with the number of relayers, your volume scales with the number of dApps, and your volume scales with the numbers of users per dApp. But this poses a problem, because now there's all of these different parties that are hooked into the exact same piece of infrastructure. So now, what happens if this infrastructure needs to be upgraded? This is a huge disruption to the network, and it's not an easy problem to solve. If there's new technological capabilities that are added onto the Ethereum blockchain, if there's new capabilities that are built into smart contracts, how does this entire ecosystem decide to collectively migrate to a new version of the protocol? That's why we use a protocol token where each person that owns a stake in tokens gets to vote in the upgrade process. So there's a decentralized upgrade process where every stakeholder in the ecosystem gets to vote on how the smart contracts are improved over time. Okay, so that's kind of like a high-level overview of 0x protocol. Now we're going to go a little bit more technical. We're going to go into how the smart contracts actually work and the architecture of the smart contracts. Before we do so, I'm going to go over a couple quick Ethereum prerequisites. This is the developers meetup, but I have a feeling that we have like a pretty wide spectrum of different people here with different backgrounds in Ethereum. So on the Ethereum blockchain, there are two different types of entities. There are Ethereum accounts, and these are what you might be used to using when you're using an Ethereum wallet. It's a public-private key pair that controls a balance of Ether. And then there are Ethereum smart contracts. And smart contracts are completely different from accounts. Smart contracts can store any arbitrary state, and they can also include methods that operate on the internal state of the smart contract. So what's important to know is that every single transaction on the Ethereum blockchain originates with an account. So smart contracts cannot just decide essentially a smart contract can't just see something happen on the blockchain and decide to sort of wake up and change its internal state. Essentially, an Ethereum account has to call a function on a smart contract, and then that smart contract can sort of set off a cascade of further calls into other smart contracts. But at the very beginning, there's always an Ethereum account. Is that clear? Okay. And so I'm going to be showing some diagrams. The white circles are accounts, the gray blocks are smart contracts. So getting back to this question I got earlier about how do you provide access to your balance of tokens? ERC20's tokens are sort of the standard smart contract to represent any digital asset on the Ethereum blockchain. And every ERC20 token includes sort of the same fundamental set of functionalities. The one that everyone probably knows and feels comfortable with and uses is the transfer function. If you have a balance of rep, you can transfer a part of your balance to anyone else. What people are less commonly familiar with is the approve and transfer from functions. Essentially what you're seeing here in this diagram is some Ethereum account. Someone owns a chunk of this ERC20 token. What they're doing in transaction number 1 is they're approving this dApp smart contract to access their balance. And then a separate transaction number 2, this owner is calling into the dApp that they just approved and essentially calling like a deposit function, which pulls the tokens in. So allowances and the approve and transfer from sort of framework, that's kind of very core to how 0x works. So the architecture of 0x. 0x has 3 primary modules. The first one, which everyone is probably most familiar with at this point, is the exchange module. So this is the smart contract that you inject these cryptographically signed orders into, and it actually authenticates the signatures. It ensures each party has the necessary balances, that orders are not expired, and it actually attempts to move the funds between the 2 parties. The second module is a decentralized governance module. And that can be seen up here on the top, in the middle. And the decentralized governance smart contract is used to essentially replace the exchange smart contract with an upgraded and improved version at the time that the stakeholders deem it necessary. The proxy contract is sort of the intermediary between the two. And the proxy contract can kind of be seen as like a valve that can be opened and shut, allowing different exchange contracts to access user funds, user trading balances. So we're going to kind of go through the process, sort of like all of the core processes that take place within this system right now. The first, probably most important process is the process of actually executing a trade. The second is upgrading the exchange contract using the DAO. And the third process is upgrading the DAO itself to a new DAO. So trade execution. As I mentioned in the prerequisites slide, every Ethereum transaction starts with an Ethereum account calling a function on a smart contract. And after that first initial function call, that smart contract can kind of trigger a cascade of calls into other smart contracts. And assuming that nothing went wrong during the transaction, you eventually end up right back where you started with the smart contract sort of returning a response to the original account. So what you see here is you see someone that received this 0x order, cryptographically signed data packet. They are injecting it into the exchange smart contract. The exchange smart contract is doing all the things that it does, authenticating signatures, verifying balances, verifying expiration times, etc. And then the exchange smart contract is calling into the proxy. And the proxy is the contract that is actually capable of reaching into user balances and moving them between counterparties. After moving the funds, sort of moving the very first batch of funds from, say, the maker to the taker, the proxy calls back to the exchange and says, this was successful, carry on. Execution moves back to the exchange. It sees that the first leg of the exchange was successful, and it says, great, let's move the other side of the trade. Let's move funds from the taker to the maker. It calls transfer from in the proxy contract, and then the proxy contract moves the funds between in the other direction. And then essentially you just kind of cascade these Boolean responses back to the original Ethereum account. So everyone feel kind of comfortable with this? There's kind of a lot going on, but at the end of the day, it's sort of just different smart contracts passing execution back and forth. Are we good?
Mention that it's atomic.
Oh yeah, okay. So what I should mention is that this is a single Ethereum transaction. There's no sort of like counterparty risk where one leg of the exchange gets executed and then the other leg gets executed in a separate transaction. This all happens atomically in a single Ethereum transaction. So now what happens when your exchange contract that used to be great, it used to do everything you needed it to do, has become dated? Maybe there's entirely new cryptographic primitives on the Ethereum blockchain, such as ZK Snarks. Maybe there's things like BLS. Maybe there's like Schnorr signatures. There's all these things that are going to be added to Ethereum. Maybe there's a different hashing algorithm. Maybe instead of using Kesak 256, we've switched to Blake 2B. Maybe there's other things that have changed on the Ethereum blockchain that fundamentally require an upgrade. Well, the process of upgrading the exchange smart contract to a exchange contract version 2 essentially requires the stakeholders in the protocol, so these are the people that own and hold ZRX tokens, to come to agreement upon how that exchange contract is going to, how people are going to migrate to this new exchange contract. So the very first step, we have this exchange contract version 2. This exchange contract, in step 1, you can see that it's attempting to do something. It's attempting to access the proxy. It's trying to reach through the proxy and handle user funds. And it's denied. It's locked out. It does not have permission to do so. So if we want to give this new exchange contract access to trading balances so that it actually can go into production, first, one of the stakeholders has to come up with a proposal to allow this new exchange smart contract to begin executing trades. So that's what we see in step 2. It's just one of the stakeholders, they have this proposal, and they're injecting it into the DAO smart contract. In the next step, the rest of the stakeholders, the people that own ZRX tokens, they vote whether they support or reject this proposal. Does the exchange contract version 2 have bugs in it? Well, you're probably going to reject it. Does the exchange contract version 2 have some awesome improvements that are going to fundamentally impact your business, assuming that you're running a relayer? If so, then you'll probably approve it. So assuming that this proposal gets approved, the fourth step is for one of the stakeholders to essentially execute the proposal. And in this step, they call execute proposal in the DAO, and then the DAO reaches through into the proxy and sets approval for the new exchange version 2 smart contract. So the approval has gone from false to true. And then finally, once this approval has been extended to exchange version 2, exchange version 2 attempts to execute a trade, and it's able to do so successfully. Everything clear? Any questions? Yes?
Is it a majority of votes or consensus?
No. So that is one of the hardest questions to answer, is how do you create a governance system that has good incentives and punishes bad behavior? As we have learned through history, majority votes are not very good. And the reason for that is because voter turnout, bribing people to vote a certain way. So creating a really good governance system is probably more sophisticated than creating 0x protocol exchange contract. And so we're working with some other projects that are focused on governance to figure out the very best way of setting up our governance system so that it can't be held hostage by a hostile minority, but can also sort of not allow sort of malicious people to get bad proposals through.
What sort of time frame do you expect for a vote to take place?
So that very much depends on how governance is implemented. And yeah, I mean, frankly, I don't know if I have a good answer because I haven't really seen good examples in production. Yeah, I don't know if there are any existing decentralized governance models that are really seeing much use at this point. What I will say is that until a really solid governance model is figured out, DAO is going to just be a multi-sig with a time block. So it's essentially, we're going to be doing a lot of R&D on figuring out how to best structure our governance model. Until that's figured out, there's going to be a multi-sig with a bunch of independent parties that want to see the project succeed. And if the multi-sig attempts to do anything, there is a significant time delay between when they pass the proposal and when it can actually be executed. So this protects user funds from the multi-sig owners doing anything malicious. So this comes to the next question. how do you upgrade your governance logic? So this is a really similar example to the last one. There's a new governance smart contract, DAO version 2, that wants to set approvals in the proxy. It attempts to do so, and it fails because it does not have access. A stakeholder submits a proposal, there's a vote, and then if it passes, someone can execute the proposal and move control from DAO version 1 over to DAO version 2. So it's pretty much the same exact model. It's just very modular. One's focusing on how do you upgrade exchange logic. The other is focused on how do you upgrade DAO logic, governance logic. Yeah.
What are some examples of why we want to upgrade governance logic?
Yeah, I mean, so I think it's really hard to build anything on Ethereum right now and just have it sort of stand the test of time. And the reason I feel that way is because Ethereum is rapidly evolving. It's only been around 2 years, and it's changing so rapidly at all these different levels in the stack that something that might be cutting edge today could be completely broken or completely dated 6 months from now. So if we're able to come up with a great governance model, it might not be that great in a year from when we deploy it. So yeah, I mean, having the ability to sort of upgrade a system over time is, in my opinion, it's extremely important. Okay, so now I'm going to talk about something that's a little more meta, but I think is really exciting, and something that 0x is going to facilitate. So who's here has read Fat Protocols by Joel Monegro? Anyone? Okay, so the TLDR on Fat Protocols is that he wrote it back when sort of Bitcoin was the only game in town. And the idea was that on the centralized internet, there's applications, and underneath all these applications is a thick stack of different protocols that make the application function. And in Fat Protocols, or in the blockchain application stack, was another article he wrote, his thesis is that Bitcoin is sort of the very foundational protocol that sits at the very bottom of the stack. And that on top of it, there are these sort of different overlay networks like Factum, and different sort of decentralized protocols built on top of those. And on the very top of the stack are sort of these decentralized applications. And what we've seen since these generation 2 and 3 blockchains have come out is that there isn't really a tendency for all of these protocols and applications to be layered on top of Bitcoin. In fact, there seems to be an unbundling where there are many different specialized networks that are focused on different things, and they have different unique incentives, and they sort of each have a token that drives whatever process it is that they're trying to facilitate. So if you were to think of a centralized web application, it probably requires quite a few things. You need computation, you need file storage, and you need payments, and all of these things are sort of taken care of by centralized services like AWS. And in the future, if we're going to have fully decentralized applications, they're probably going to be made up by a stack of different protocols, and where each one sort of has its own unique token. And so, for example, the Ethereum EVM is extremely limited in its computational capabilities, and it's also extremely limited in its ability to store data. It's just way too expensive to do very much on the Ethereum blockchain. So if you want truly scalable computing, then you'll probably have to use something like TrueBit. And TrueBit, what they're trying to do is allow anyone to sort of do sort of complex, arbitrarily complex computation off of the blockchain, take the result and a proof of how that result was attained, and inject that into a smart contract. And verifying the proof is relatively simple. Another example, decentralized file storage. So Filecoin and Swarm are two, there's also a variety of others, are trying to decentralize Dropbox. So if you have a bunch of gigabytes of data stored in Dropbox, you know, they could get hacked. It's a centralized service. Essentially, you can just pay people for their spare file storage space on their personal computers. Another sort of example of a decentralized protocol that might be needed in the decentralized application stack is a decentralized Oracle protocol. So how do you take data that exists off of the blockchain, so real world data, and how do you inject that in a trustworthy way into a smart contract? So that's a problem that I would argue Augur has solved with their reputation tokens. You can use a centralized service like Oracleize to, you know, say, hey, trust us, we'll tell you the current exchange rate for Apple versus USD, and we'll inject that into your smart contract. But what happens if they get hacked? What if they're dishonest? Well, Augur, you know, if what you're attempting to inject into a smart contract has a real financial impact on how money is moved, you might want to rely on something that's a little bit more fault tolerant, like Augur's reputation tokens. Hey, Jack. And so with Augur reputation tokens, a bunch of different people that hold rep tokens essentially come to consensus on the outcome of a real world event that happened off of the blockchain. And they sort of inject this result into the blockchain and sort of vote on you know, the validity of the data. So the idea is that in 5 to 10 years from now, a fully decentralized application that you're using, to, you know, you might not even realize underneath the surface, there's all these different protocols that are sort of stacked on top of each other, and they're creating this unified user experience on the front end. So what might it look like if you're interacting with a fully decentralized application? And what happens if you have to interact with all of these unique decentralized networks? Well, in this simple example, you have to have a bunch of different tokens that drive these different protocols. So let's look at an example where you have a smart contract that needs to go fetch some data. Maybe it's using the Filecoin network, and you're grabbing a whole bunch of data. Next, you're passing this sort of data set into a scalable computation solution like TrueBit. All of this data is processed, and you get a proof, and you get a result, and this result is passed back into your smart contract, and then the smart contract does something in response to the result. Well, you could possibly do it this way, where you have a whole bunch of different tokens, and you own them, and you have to kind of have a constant balance of them. But a lot of people don't really want to have a whole bunch of tokens. They aren't necessarily interested in, or they don't have a vested interest in holding on to these, you know, highly volatile assets. They just want to access the service. They don't care about Filecoin. Not everyone's really passionate about decentralized technology. So what's the solution? How can 0x help this? So 0x provides something called token abstraction, which is something that we haven't really talked about in depth in a presentation before, but it's something that we think will be a real use case for 0x. And in token abstraction, the end user of a fully decentralized application, they don't have to hold on to all these different tokens that power all these different decentralized networks. Instead, maybe they pass in some USD pegged fiat tokens and a stack of 0x orders into a smart contract. And what that smart contract will do is it will synchronously pass these orders and these tokenized fiat tokens to 0x, and it will execute a bunch of trades synchronously and behind the scenes without the user ever knowing. And these USD fiat tokens will be converted into all their respective tokens needed to power the decentralized application. And then the smart contract will go on its merry way. And all of this will happen behind the scenes without the end user ever knowing or caring. So we think that token abstraction is something that's going to be needed in the future if we're really going to see all these distinct decentralized networks that provide different sort of functionality. So thank you for attention. That was like the technical overview of the smart contracts. Now Fabio is going to come talk about some of the awesome things that we've built. So you can see some of the cool stuff we built and how you can use 0x protocol. Thanks. Thanks, Mark.
Hi, everyone. So the first thing that I'm going to be talking about is OTC. So 0x, we've deployed an over-the-counter trading dApp. What this allows anyone to do is trade with a known counterparty. So if you know who you want to trade with, without any fees, you can generate an order, send it to them, and then they can fill it. So here you can see someone filling out the amount of Augur tokens that they want to trade for Melon tokens. They can set an expiration date, even specify the taker, and then they have to sign the order here using MetaMask. And then they can broadcast this to their counterparty. Maybe they can tweet it out, or they can send it through a Facebook message. And the other person can then take it and fill it on OTC. So this is live today on the Kovan testnet. After we're done with the security audits of our smart contract, they will also be, you can also use it on the mainnet. The other thing that we've been working on is OX.js. So this is a JavaScript library. You can kind of think of it as Web3, but for 0x. And what this is trying to solve is one of the challenges of building a decentralized exchange. The four main challenges you're going to face if you're going to build it without 0x is writing efficient, secure smart contracts, hooking into these contracts from a client-side web app, hosting an off-chain order book, and then providing a really great user experience. So 0x's smart contracts does the first really well. You don't have to worry about writing your own settlement exchange smart contracts. And OX.js solves the second one by providing a JavaScript interface that lets you interact with the OX protocol without knowing anything about smart contracts. So you don't have to deal with artifacts or anything like that. Literally just JavaScript functions. Here I just want to show you guys, we spent a lot of time making documentation for the library, so please check that out on our website. And the next thing that I want to show you guys is like a real world example, or actually two examples of using OX.js. So in order to make it such that you could run this example at home, there's a bunch of setup here, but this is the main part of the code. So here you can see a signed order. So this is an order that has already been signed by the maker. And in order for someone else to come and fill this order, they just have to call 0x.exchange.fillOrderAsync. They pass in the order, the amount of the order that they want to fill, and they specify themselves as the taker. And calling this, so when you call it, essentially this transaction is going to be signed by the taker, broadcast to the network, and mined into the next block. And once it's mined, you can actually see here in the trade history, let's see this. Oh, yeah, there it popped up, but I hit refresh too fast. Let's let this. Oh no, the law of demos. Let's actually look over here in the smart contract. So yeah, here you can see this order just came in 20 seconds ago. And if we click in on that, you can see that in one atomic transaction, both tokens were transferred atomically. The second example that we want to show is an example of token abstraction. So what we hear a lot from people is like, okay, you guys are introducing this new token, 0x. Isn't it going to be a pain if everyone needs to hold a balance of 0x tokens along with what they want to trade? Well, use token abstraction. So the end user can pay 0x fees to a relayer in Ether, or wrapped Ether in this case. Just quickly, wrapped Ether is Ether wrapped so that it complies to the ERC20 specification. But essentially it's the equivalent to Ether. So here you have two orders. The first one is just converting wrapped Ether into 0x tokens. And this the relayer would do without any fees attached to it. And then the second order is the actual order that someone's interested in doing. In this case, they want to trade Golem tokens for 0x tokens. So they would essentially call this method called batch fill orders async, specifying the 2 orders and the amount that they want to fill for each one. And we can execute that here. And again, this is going to be done in 1 atomic transaction, which is really cool. It means the end user does not need to own 0x tokens to use the 0x protocol. So that went through. Let's see if it's popping up over here. Yeah, I think that's it. Let's see. Yeah, and here you can see that all the different transfers of 0x tokens, wrapped ETH to 0x tokens, and then Golem tokens for 0x tokens happened in a single transaction. That is it for the demo. Will, do you want to come back and finish up?
Thanks, Fabio.
So I just want to recognize Leo and Fabio both worked super hard on 0xJS, and you can find the docs on our website. Really awesome docs, very thorough. You can start hacking on 0xJS today, create any sort of decentralized application that executes trades. It can be an exchange, it can be an auction platform, doesn't matter. So just a couple more things before we wrap up. In September, we're planning a hackathon called 0x Hack. We put a ton of effort into this slide. There's remote participation's okay. The idea is that people can build prototype decentralized applications using 0xJS. They can write smart contracts that plug into 0x protocol. There's going to be some great prizes. If you're interested, if you're a student or not, if you've graduated, whatever, or either way, if you're interested in sort of getting a foot in the door in the Ethereum ecosystem as like a career, this might be a great place to start. You can potentially get seed funding. There's going to be some VCs that are going to be watching. There's also going to be like an awesome judge panel. So I think it's a really good opportunity. The details are still being sort of figured out. We're really busy right now planning for our launch next month. But yeah, follow us on social media and the details about the hackathon will be forthcoming. Just a really brief overview of our project. Yep, so Amir and I started working together in October. We both sort of quit our original career paths to focus on Ethereum full time. In February, we released the 0x white paper, and we deployed our smart contracts to Kovan in March. 0x OTC launched on Kovan around May. That was around the time that Fabio joined us. 0xJS open sourced just last month. It was around the same time that Leo joined us. This month, our security audits for our smart contracts are going to be complete, which means that once we get the thumbs up, we're going to put 0x protocol on the Ethereum, the mainnet. So it'll be live and you can trade. Next month, in August, we're going to do our token launch. So the ZRX token, it's used to pay transaction fees to relayers. So if you want to be making trades using 0x protocol, you might want some 0x tokens to pay for your trades. It's also used for decentralized governance over the protocol. So if you're planning on building a decentralized exchange or some sort of app that is built on top of 0x, it might be a good idea to participate in governance. There's going to be a mandatory registration period for the launch, August 9th through 12th, and then we're actually going to launch our token on the 15th. And then in September, we're going to run our hackathon. You can keep up with our progress on 0xproject.com and on GitHub, Slack, and Twitter. There's lots of developments coming out all the time. Yeah.
Is the token launch for U.S. citizens or is it for U.S. citizens blocking?
So we're still working with our legal counsel. Yeah, it's not an easy question to answer. I wish I had one.
Sure.
Yeah, so thank you very much for your attention. We appreciate it and your patience. We're going to take questions now. Yeah.
Yeah, I guess I just wasn't clear about the race conditions. Can you explain a little bit about how you can solve that?
Right, okay. So if there is an order on, say again?
Repeat the question.
Okay, so the question is, how do you deal with race conditions? So there are multiple ways that you can deal with race conditions. And by race conditions, we're talking about multiple people attempting to fill the same order within a single block time. One of these people is going to fill the order. The other person is going to have a failed transaction, which is bad. So there's a few different ways you can solve for race conditions. The first way is that the relayer, instead of essentially just exposing their order book to anyone that wants to sort of take an order off of it and inject it into the blockchain, the relayer can sort of act as a centralized matching engine. And so what this means is that the relayer takes orders from each side of the market, and the orders all specify the relayer as the only person capable of executing that trade. And what this means is that the relayer will get orders on each side of the market. They each specify the relayer as the person that can fill it and the only person. And then when the relayer gets two matching transactions on opposite sides of the market, they will package these two orders together and batch fill them in a single Ethereum transaction. And so this completely eliminates the possibility of anyone else attempting to fill one of those orders on that order book. Another possibility, and this is something we were considering earlier on in the project, but we decided against, is that you can create your own custom deposit contract. So if you want people that are trading on your exchange to essentially lock up their funds in a way where they're still, they're not under your control, you're not the custodian, but they prevent the person that's creating orders from pulling out the funds, you can create your own custom smart contract specifically for your exchange where people that are trading are depositing their funds into the contract, and essentially they're time locked based on whatever sort of logic you want to implement. Yeah. Yes?
Yeah, I think this is really cool. Thank you for that. I think that it seems very natural that ERC20 tokens have some sort of protocol in it. My question has to do with decentralization of the exchanges. It seems like exchanges are almost by definition somewhat centralized because you need people together. So I'm wondering, what are the advantages of having decentralized exchanges rather than having a highly similar model that you control the exchange, you control the underlying proxy contracts, and then you don't have to have this DAO and governance, you can just unilaterally change it.
Yeah, so that's a good question. The question is that, or essentially the comment first is that relayers seem sort of centralized in that the order book is stored in a central location off of the blockchain, which is true. Relayers will probably host an order book in a centralized database sort of early on. And what are the trade-offs of sort of centralizing the orders versus decentralizing them? Is that correct? Right. So one thing, so two things to point out. So first of all, the centralizing orders into a single location tends to be more efficient in terms of how you can sort of propagate data really quickly through a network. So there are certainly advantages to centralization versus decentralization. I would argue that sort of decentralizing the settlement layer and sort of eliminating the need to trust a relayer or an exchange, that's sort of where the majority of the vulnerability exists. So if you can sort of remove the need to trust an exchange, that's already a huge step forward. So this is something that we've been sort of talking about since early on in the project, but this is not like this is like an entirely new undertaking that we're not focused on for now, is we want to decentralize the order book. So we want to create sort of a relay protocol that moves the order book from a centralized database and sort of moves it into a peer-to-peer network that is censorship resistant, and that each node in that network sort of gets a portion of transaction fees that's in line with how much work they put into propagating the order book to other nodes. But that's that is a significant undertaking. That's like an entirely new phase of the project. So for now, we're quite satisfied with allowing the order book to remain in sort of like a central point with different relayers hosting their order books from different sort of servers.
Go ahead.
Why is there a need for 0x tokens? Like, why can't the relayers be paid with the token that they're exchanging?
Right. So the question is, why is there a need for ZRX token rather than like Ether or like paying a percentage of? Yeah. So the answer to that is that there needs to be a way to upgrade the system over time. And if you can't do that, essentially what's going to happen is that each relayer is going to sort of identify a feature that they want to integrate into the exchange smart contract. No one else is going to be, well, they're not going to be able to upgrade the smart contracts. So essentially what they'll do is they'll take the 0x smart contracts and they'll fork it and they'll add the new feature that they want. And each relayer will essentially over time do the same thing. So each relayer will kind of create their own forked version of the protocol that have different features that are specific to that relayer. And we'll kind of end up right back where we are right now, where there's a bunch of different custom and proprietary smart contracts, and they're each highly illiquid. There's like no standard tools available for creating your own exchange. And so the governance process is like extremely key. It's like extremely important to maintaining the network effects that are generated by having an open standard. And the reason why you want the token to be used for paying trading fees as well as for governance is because you want the incentives of the end users, the people that are trading, to be highly aligned with the stakeholders. So you want the people that actually own the system and are able to upgrade the system, you want them to have the same incentives as the people that are using the system. Otherwise, what will happen is the people that will own the system will make changes to it so that they can extract rent, so that it's no longer free. So yeah, the short answer is that you need to have aligned incentives between the traders and the owners. Yeah.
So what I was getting out of the person actually filling the order sends the transaction to the network, right? So they're the ones actually paying the gas for the transaction. And so that means there's actually two pieces of it. One to just and the other to the relay. Correct. So in a way, is that kind of like offsetting the cost of doing the whole exchange process to like two parties, or would you say that exchanges just kind of gone up because you're paying both fees? You get my question?
Yeah, I do. So the question is, so what you're saying is that if you take an order and you send it into the smart contracts to execute a trade, not only are you paying gas costs, but you're also paying a transaction fee to the relayer or the exchange that was hosting that order. Right, so a couple things. So first, the protocol is completely free to use if you don't use a relayer. So like if I know you, you're my friend, you're in my social network, and I say, hey, you want to like do a private over-the-counter trade at this rate? Like, sure. It's completely free other than the gas cost. But if we want to go to a off-chain order book that has a whole bunch of liquidity, a whole bunch of people that are wanting to trade, well, hosting and maintaining that order book is not free. If relayers are unable to sort of generate any revenue, they'll have zero incentive to actually offer that service. So if I had to guess, I think transaction fees will sort of quickly reach like an equilibrium where they're sort of offsetting the costs of hosting this off-chain order book plus like a profit. So even though you're paying for the service of an off-chain order book, this is still like orders of magnitude cheaper than using an on-chain order book. An on-chain order book is just insanely expensive. So yeah. Yeah.
Do you offer
like for the relayers, like bid and ask prices, or like, for stocks, like you said, let me get in at the current market rate, or.
Oh, so you're saying like market trades?
Yeah.
Right.
Or
So
like bid down once it drops below a certain point, or liquidity at that price where the relayer goes to a certain level, or price point.
like stop, like placing stops.
Yeah, or like I don't want to buy from this relayer because it's too expensive, but if he drops his price at a certain point, then I'll buy from it.
Oh yeah, yeah. So that can all be done like programmatically off the blockchain.
Okay.
Can you
So-
repeat the question?
Yeah. So the question is, do exchanges that are built on top of 0x protocol support like market orders, or also like limit orders or stop orders? And the answer is that is like completely at the discretion of the relayer. So that's like a UI UX thing that can be, that can definitely be implemented by the relayer.
Okay.
But the protocol itself is very, it's opinionated in how orders are structured, but not in terms of like the user experience or like, yeah.
Would you say that decentralized order books are important for the success of 0x long term?
No.
Okay.
No, because it's trustless. So centralization is great for some things. Decentralization is great for censorship resistance. So like, if you wanted to set up a relayer in a jurisdiction that would send you to jail for doing that, or censor you, then you might need a decentralized order book that can't be sort of shut down by a government. If you're able to operate a relayer in a jurisdiction, I don't really see why, making the order book decentralized in a place like that would just be more expensive. Yeah.
I think you said this was a ways off. I'm just curious. So the phase where you're decentralizing the order book, do you have a rough strategy for doing that without putting that on the second blockchain?
That's a hard question, and I am not sure. Maybe it might have to be a separate blockchain, or it might have to be like a tangle, like the IOTA tangle looks interesting. But the short answer is it's a really hard problem, and that hasn't been our primary focus. Yeah. Yes?
So relators, I think that nature is very centralized. So in the future, do you think there will be many relators in the market, or only a few of the relators that can manipulate the market? Is there a danger for that?
If relayers centralizing and then manipulating the market, is there a danger for that?
Okay, yeah. So is there a danger in relayers, since they're sort of centralized in like manipulating markets and stuff like that? So I think what's going to be like really interesting is creating a decentralized exchange on top of 0x protocol is going to be like pretty easy for someone that's like an experienced web developer. So like the barrier to entry is going to be pretty low. And I think that there will be a bunch of relayers, and they'll all be competitive. There will be competitive transaction fees. There will be low switching costs. And if you're a relayer and you're acting dishonestly, I think there will be many other options. People will quickly find out, and then they will quickly shift over to a different relayer. That's kind of my gut instinct, but I could be wrong. Yes?
Do you subscribe to Vitalik's notion of like a world of thousands of tokens?
Yeah, absolutely, but maybe not ICO tokens. Like, if I had to guess, like 95% of the ICO tokens we see today are going to go to zero. But like real assets that actually have value or utility, like I think stocks will be on the blockchain. I think gold is already on the blockchain. Things like fiat will be on the blockchain. Like one thing that's like insane to me is that if you're not based in the United States, you cannot access, like for the most part, you cannot access stocks that are on the US stock exchange. Like if you are in India or China, like it's really hard to invest in like Apple or Google or like all these other amazing investments. And like we're just super lucky here because of like what I would argue are like not very free market regulations. So like, if you can take a stock and move it onto a global and open financial system or network, then like I think there will be enormous demand for that. So if you can tokenize stocks, like there's going to be people like beating down your door trying to access them. Yes?
If you guys are eventually going to be governed essentially, how do you and your team see yourselves playing a role?
Yeah, so we're structured very much like the Ethereum Foundation. So we're raising money, much like the way the Ethereum Foundation did back before the Genesis block of the Ethereum blockchain. And 100% of the money we raise is going to go back into open source software tools and infrastructure that support the protocol. So we're not like trying to, the protocol's free to use. We're not getting like payouts every time someone uses it. So like our focus is really on sort of developing the ecosystem and creating tools for people. So I think we'll probably be somewhat like the Ethereum Foundation. Yes?
Will you guys build relays yourself?
No, that's something that a for-profit company would have to do.
Do you have any already of these cryptocurrency exchanges interested in using 0x?
Yes, multiple, but I can't tell you who.
Okay.
So if I'm on a relay right now, do I only have to use 0x or else have to use like Web3?
0x.js, which Web3 is a dependency for 0x.js, but it shouldn't be that difficult to like get a somewhat functional prototype up and running. So thank you for the questions. I'll be around if you want to talk.